Good morning. In today's class, I'll be discussing about real numbers. This is the first lesson in your 10th standard mathematics. Okay. Now let us try to understand the topic 3 of this chapter. Take down. There will be an introduction part and we'll be discussing about the number system, whatever we have discussed in the previous classes. Just it will be a recap. Then real numbers, ration numbers, Euclid's lemma, what is HCF, then factor tree method, Euclid's division algorithm, and we had to show that square root 2, square root 3, these are all irrational. So this is the topic 3. As I already mentioned, we will discuss the real numbers, ration numbers, Euclid's lemma, HCF, factor tree method, Euclid's division algorithm. Then we will prove whether root 2 is irrational. Similarly, other surds like root 3, root 5, etc. Under real numbers, we will be discussing fundamental theorem of arithmetic. Okay. Then Euclid's division algorithm. And the real numbers can be classified as ration number and irrational number. Usually this Euclid's division algorithm, it is useful to find the HCF of two numbers, and this is called Euclid's division lemma. That is, A is equal to BQ plus R. A is equal to BQ plus R. For example, as I already mentioned, the ration number can be represented by P by Q form. Let us have, say, that is 65 divided by 3. So when it is divided by 3, that is 65 divided by 3. So we get 2 3s are 6 and 5 1, that is 3. So the balance is 2. Is it not? So this is called this number is called dividend. What do you mean by dividend? The number that is to be divided. And this is called divisor. And this is called quotient. And this one is remainder. Not reminder, remainder. Right? And now we can get this dividend. 65 is equal to divisor into quotient. Is it not? That is 3 into 21 and add the remainder, that is 2. So what will you get? 3, 6 plus 2, 65. Okay. So this 65 can be illustrated like this, and this is what done by Euclid. So this is called Euclid's division lemma, and this is represented as A, that is dividend. So A represents dividend here, A, and then 63, 3 into 21. What is this 3? That is the divisor. Okay, so you can put B is the divisor, right, into quotient, that is Q, plus the remainder R. Is it clear? Therefore, A is equal to BQ plus R. Got it? And P by Q is the rational number. And what is the condition? This is the rational number format. The condition is Q is not equal to 0. Otherwise, what will happen when you put P by 0? It becomes infinity. Okay? So this is rational number. Now let us discuss about the real number as a whole. So real number, it is something like an universal set where we have rational number, irrational number, fractions. So these rational numbers are fractions, and it can be integers, and if it is integer it can be negative integer, and then positive numbers, then whole number, and we have got the natural number, and you can include 0. So it means the natural number is represented as n, 1, 2, 3, etc. And the whole number w,
0.
You have to include 0, 1, 2, 3, etc. And z is the integer that includes negative, 0, positive numbers. That is, you have ... -3, -2, -1, 0, 1, 2, 3, etc. Okay? Whereas the rational numbers, they are represented in the P by Q form. So it can be either in the fractions or can be decimal also. For example, 1 by 2, where P is equal to 1, Q is equal to 2. This can be represented in the decimal form also. How? 0.5. Okay? And these two can be interconverted. If you want to convert this one, you have to divide 1 divided by 2. So 0. Then you can add 10, and then how much? 5 times 0. Is it not? Similarly, this can be converted into fraction. How? That is 0.5 and multiply and divide by 10. So it becomes what? 5 by 10. So you can strike out and becomes 1 by 2. So likewise, we can convert the decimal into fraction and fraction into decimal. And the irrational numbers are irrational numbers. These are all rational numbers. Irrational numbers and rational numbers. Let us have the classification or difference. The rational number, as I already mentioned, can be fractions P by Q, this is also represented as P by Q. In both the cases, Q is not equal to 0. Secondly, ration number can be, that is the decimal. It can be a decimal. This is also decimal. But this decimal here, it may be that is repeating, non-terminating, NT, but recurring. Or fixed. It means you can mention this as 0.5. And when you divide 1 by 3, it becomes 0.3333, etc. It goes on. So non-terminating. Are you able to understand? Non-terminating. In this case, it is fixed decimal. And what about recurring? That is 0.3333. There will be a repeated pattern. So you can put this as 3 bar. So this is recurring. But here also it can be represented in the decimal form. But the problem here is it is not fixed. You cannot fix it. It's not stopped at one place. Then it is non-terminating. As well, it is non-recurring, NR. Okay. For example, here you can include square root 2, square root 3, pi value. So these are all having decimals but non-recurring. There won't be any pattern. In the case of a square root 2, that is 1.414, and it will be not repeated. Similarly, root 3, 1.732, it goes on but with different patterns. And the pi value will be 3.14 with the different patterns. Are you able to understand? Okay? Please note down. Next. You can note down this summary also. The real numbers can be represented in various ways. Real numbers may be prime numbers, may be co-prime numbers, integers, rational, irrational, composite, natural, whole number, even number, odd number. Okay, take down. So let us talk about the odd number. What about the odd number? 1, 3, 5, etc. These are all odd number. What about even number? That is 2, 4, 6, 8, etc. And whole number, or you can say natural number. Natural number 1, 2, 3, 4, etc. And what about whole number that includes 0 also? 1, 2, 0, 1, 2, 3, etc. And ration number, let us have whole number, then integer. Integer means minus dot 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 minus 2, minus 1, 0, 1, 2, 3, etc. And ration number means you can have any number in between that, is it not? For example, between 1 and 2, you have got 1 by 1, 1.5. Between 1 and 2, 1.5. And you can also write to 1.1, is it not? 1.1, 1.2, okay, 1.3, 1.4, etc. So in between you can have lot of fractions. Let me consider only these two. Between, we will draw a number line 1, 2. You can write a fraction in between this. What is that? That is 1.5, that is 1.5. And in between these two, 1.25. In between these two, 1.75. Likewise, you can go on splitting, and that can be represented, for example, 1.5 can be represented in the what? That is fraction form, that is 3 by 2. How you can write 1.5 divided by, 1.5 multiply and divide by 2. So you can get 3 divided by 2. So 1.5 can be written as 3 by 2. So likewise, it can be represented in the fractions or decimals. Ration number, irrational number, they are root 2, root 3, root 5 and pi, etc. Okay, because they are all non-terminating, non-repeating, that I have already discussed. And you have got the composite number. For example, if you take 16, that can be factorized as what? That is 2, 2 twos are 4, 4 twos are 8, and then 2. Okay, you can further split it. Composite numbers will have some what? Factors, so they are factorizable. And what about the prime numbers? The prime numbers can be divided by 1, or it can be divided by itself. For example, 3 is a prime number. Either it can be divided by 1 or it can be divided by itself. Okay? It is not factorizable by any other number. Clear? So this is regarding the complete system of numbers. Okay? Do you understand? Now let us work out the HCF, that is highest common factor. Take down HCF. What do you mean by HCF? Highest common factor. Take down. Find HCF of 120 and 35. Okay. Now we have 120. you had to divide this by 35, right? How many times? 3 5s are 15, balance 1, 3 3s are 9, 3 5s are 15, balance 1, 3 3s are 9, plus 1, 10. Okay, now 5 and this is 15. You can bring this 35 here. Now divide further. So 2 times, how much? This is 30. Again 5. You can bring this 15 inside.
3.
So 3 times and this 15. So 0. Now when the remainder becomes 0, that divisor should be taken as what? The HCF. Okay, this is the HCF. So the HCF is 5 for 120 and 35. It means 120. Let us factorize. 120, you can go ahead with the 2. 6 2s are 12 and 0. Again 2, 30. Again 2, 15. Again 3, 5. Got it? So 120, 2 power 3 into 3 into 5, right? And what about 35? 35 can be factorized as 35. 5, 7. So 5, 7. Now which is the common factor here? 5. And this is the highest common factor. So you declare HCF as 5. Okay. So you can adopt both methods. One is the division method, other one is the factorization method. Do you understand this? Okay. Right. Next. Now let us talk about the fundamental theorem of arithmetic, where we will be discussing about the composite number and how they can be factorized as declared as a product of factors, prime factors. Take down fundamental theorem of arithmetic. Every composite number, take down, every composite number can be factorized as product. Factorized as product. Factorized as product of prime numbers. In fact, this factorization technique is unique, and let us have this express. Take down this problem. Express 210 as a product of its prime factors. Okay. Now 210 is equal to, let us work out, 210. Always go by the smallest prime numbers. What are the prime numbers? 2, 3, 5, 7, then 11. Not 6. 6 is a composite number of two prime factors, 2 and 3. Okay, as I already mentioned, what do you mean by prime factor? That can be divided by 1 or by itself. Okay, right. So let us start with 2. How much? 10 2s are 20, 5 2s are 10. Again, it is not divisible because it is odd number. and it ends in 5. So we can try with 5.
21.
And better, I would also suggest whether it can be divided by 3. So for which you should know the
Yes, sir.
test of divisibility. That is very important. Take down. Test of
25.
divisibility. What do you mean by test of divisibility? For example, if you want to know whether a number is divided by 2, it should be the last digit should be even number or 0. That should end with even number or 0. For example, 24. You can instantly say this is divisible because 4 is divisible by 2. And you can say that is 100. Whether it's an even number, it is divisible by 2. Yes, because you have got 0. So likewise, in the case of 3, you have to add the digits. For example, let me consider 105. Add all the digits 1 plus 0 plus 5. How much? 6. So that is divisible by 3. Okay. So you can declare that is divisible by 3. Similarly, for 4, the last digit, for example 2024, it is not prime factor, but even then you should know how to test. So 24, you have to consider the last 2 digit and check whether divisible by what?
4.
4. Now can you tell me 2024 whether it is divisible by 4?
Yes, sir.
Yes, and that is why it is a dash year.
This year.
This year is dash year.
Leap year.
Leap year, that's good. Okay. And similarly for 5, for example, you have got 215 means it's divisible by 5, and also 310 means it should end with 0. Okay, so 0, 5. So for 6, you can try with 2 and 3 if it is a even number and also works for 3. Then you can declare it is divisible by 6. So likewise it goes. And also for 9 it goes. For 8, last 3 digit. For 9, it should be the multiples of 9. The sum of numbers will be 9. For example, 81 means 8 plus 1 is equal to 9. So that divisible by 9. Now let me come back here. So 105, 1 plus 5, 6. So 3. So 3 3s are 9. And what about this? 5 3s are 15. Correct? And then 35. 35 means 3 plus 5, 8. So it is not divisible by 3. Let us go ahead with 5 because it is the last number is 5. So 5. So 7. That's all. So what are the prime factors? 2 into 3 into 5 into 7. So all are prime factors only. So multiplying these prime factors, you are able to get the composite number. And these are all called prime factors. So do you understand this? Okay. Can you work out the HCF of? Can anyone try this?
Sir.
Try. Find the HCF of. And now this time let us have HCF and LCM both. What is HCF?
Highest common factor.
Yes, highest common factor. And what is LCM?
Least common multiple.
Least common multiple. Okay. Now, find out the HCF and the LCM of 12, 60, 72 using prime factorization method. So you have to adopt the prime factorization method. Let us factorize. Let me have 12. So you have to adopt the prime factorization method. What do you mean by that? You have to divide by prime factors. Okay. So prime factorization method. Now let us add 12. So what are the factors to 12? Start with 2, prime factor. How much? 6. Again 2, 3. So this is 2 squared. Is it not 2 into 3, which is nothing but 2 squared into 3, right? Got it? Then what about 60? Can you tell? 60. Tell me. 2. 30. Speak aloud.
2,
15. Then
3.
3. 5. So this is 2 into 2 into 3 into 5. It means 2 squared into 3 into 5. And 72. So let us have 72. Now try 2. How much?
26.
36. 2.
18.
18. 2.
9.
And then
3.
3. So 2 into 2 into 2 into 3 into 3, which is nothing but 2 cube into
5.
3 squared. So likewise you have to organize these prime factors. Now you must remember, what do you mean by HCF? HCF is the product of smallest powers. Take down. This is another definition. HCF is the smallest, even though it is the highest common factor, but when you interpret, you have to do like this: smallest, take down, smallest, that is product of smallest powers. You understand? Of common factors. Okay. Now what are you supposed to do? Find out the common factor first of all. Which are the common factor here?
2.
Here 2. And anything else?
2.
So here also 2. These are the common factors. And 3 common factor. Okay. So 2, 3. What I told? If it is a 2 squared, 2 cube. Which is the lowest power?
2 square,
So you had mentioned 2 squared. Got it? And which is the lowest power in 3?
3,
3 only. Here you have got 3 squared. This is 3. So you can mention 3. Now 2 squared is 4 into 3. So you can declare this 12 as the highest common what? Factor. Do you understand this? Now let us proceed with LCM. What is that? LCM. LCM can be the product of, please take down, product of. LCM can be the product of greatest powers. Okay. So if it is a least common multiple, but if it is expressed as the product of prime factors, that is common factors, it should be the product of greatest powers. Okay. Do you understand? Greatest powers of prime factors. Prime factors only. Okay. Now, which are the you need not worry about the common factor here. You have to mention only the prime factor, and you have to consider the greatest power. So, which is the greatest power here? 2 cube. Is it not? So you have 2 cube. Are you able to understand? And which is the as far as 3 is concerned, which is the greatest power? 3 squared. So you have to consider 3 squared.
Into 5.
And which is another, it need not be common. Do you understand? Okay. So you have to include 5 also. So in the case of HCF, we considered common factors. Among the common factors, you have to select only the lowest powers. Okay. But in the case of LCM, you have to consider only the prime factors, not common factors, but prime factors with highest power that you have to consider. So you go to various prime factors. What are the prime factors available here? 2, 3, 5. You write all these things and take the highest power. Which is the highest power? 2 cube. So 2 cube. What about 3? 3 squared. What about 5? 5. That's all. So 2 cube is 8.
360.
3 squared is 9. 5. That's all.
360.
So 5 8s are 40. 40 into 9 means 360. Now you can declare that is 360 as the LCM. So do you understand this? Okay. So for LCM you can have another technique also. Have you noted down? Now we can do simultaneous factorization also. For example, to find out LCM. See, that is 12, 60 and then 72. So go by the lowest prime factors. 2. 6 2s are 12. What about this? 30. This one 36. Again 2. 3 2s are 6. This is 15. 2s are 30. And what about this? 18. Okay. Again 2. You retain this. But this becomes 9. Na? Okay. And again you can divide by 3. So 1, 5, 3. Okay. So in that case, now you can once again divide. Okay. So retain 1, 5 and 1. And again by 5. So retain 1, 1, 1. So till you get 1, 1, 1. Okay. So now 2 cube. Right? Do you understand this technique? And this is 3 squared. And this is 5. So 2 cube is
8.
2 cube into 3 squared into 5. That is 8 into 9 into 5. Again 360. Do you understand this technique? Okay. So this is called the simultaneous factorization by the prime factors. Okay. So in today's class we started with the contents of what? The real numbers, where we discuss about the different types of numbers coming under real number, like odd number, even number, whole number, natural number, rational number, composite number, irrational number, then integers, co-prime and prime numbers. And we know how to do LCM and HCF. And we already discussed about the Euclid's division lemma. Okay. So we will continue in the next class.